Check, check, check. Check. Hello.
This is actually.
The levels are you running it?
Do you know where Tom and/or Philip is?
You can help me. Sorry. Can you help me? Can you run the string? You know how to do it. Check 1, 2. Check. Check. Which one is it? Check 1, 2. Check. 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 Can you guys hear me? No.
Was.
Let me try the other one. Check, check. Oops. Check, check, check. Check 1, 2. Check, check. Where is the one?
Okay, let's try it.
Oop.
Yeah, found it. No, it's right.
Check 1, 2. Check. There we go.
Turn that down.
How's that? Check. All right. This is what happens when Wes runs the. Do you guys got it? Are we streaming? Sure. Jeez. Are you sure? Are you good to go, Jason? You good? All right. Welcome, everyone. Thank you for being patient with us. This is our September meetup. Thanks to Square for hosting it. First up, we have Jesse Peterson, who's actually going to be Zooming in. He's doing this remotely, so we're really excited about that. I totally skipped over Wes's remarks, but I'm sure he didn't have anything good to say anyway. Then we have James. Where's James? Where is James? Are you serious? Okay, hopefully we have James. Find out where he is. And then hopefully a few of you can head over to the beer hall and we can continue the conversation. So let's go to Jesse.
Is earlier mic muted so you can't hear us?
Hey, Jesse, can you hear us?
Yep, I'm here.
Awesome. Are you going to be sharing your camera? Or are you going to be hidden? Oh,
Yep.
There you are.
Sorry, just 1 second.
Yay, Jesse! Yeah.
Howdy. We all ready?
Yep.
Ah.
You're good to go.
Okay, thank you. All right, thanks, Donna and Andrew for the invitation, and all the folks at Macbrained for putting this on. Greetings from Seattle. I'm Jesse. I work at an IT consultancy up here called MacTex. Maybe you've seen me around the IRC channel or in various places, Twitter, etc. But I'm hoping to talk to you today about tools and scripts and connecting those to web interfaces. Yeah, so if you're already familiar with web development, some of this may be a bit of a review, maybe a little basic. But the intent here is that if you've never done any web scripting, hopefully we can get you bootstrapped. Yeah, so let's get started. So maybe you have a tool or a script or something that you've developed or that you like to use, but it's all command line based. And that's fine for when you've got the convenience to open a terminal or something like that. But when you don't, or you don't want to, or you'd like to give access to maybe someone who's not as adept in the terminal or something like that, maybe you want to connect that to a web interface so that anyone can get to it at any time, as well as it's just quicker, who doesn't have a web browser open. And so the intent here is, how do we get from these terminal applications into a web application, or at least a web interface? So first, a little background on how web requests work. And just to let you know, this presentation is kind of in two parts. One is a little background theory to support the various things we'll be talking about, and then the second half will be the demo. And you're welcome to follow along. Hopefully, you had a chance to look at the preparation steps to get your web browser set, or your web server set up. Yeah. So, how when browsers connect to servers, it's kind of a round trip deal. So you're all familiar. You either follow a link, or you open or you type in a URL into the browser bar, and a bunch of stuff happens there in the background, such as looking up DNS names to find IP addresses. And then your browser connects to a web server and sends it a web request. And so the web server interprets this data, and typically a file is simply read from the server, like a file system, much like your own file system. And that's fine and dandy for static files that never change. But yeah, so that file is read, and then the response is sent back to the browser with that static content. So it's just reading a file and handing it back to the client. And then the browser renders that file in whichever way is appropriate. If it's an image, it shows an image, obviously. If it's an HTML document, it will render that and lay it out, etc. And that works for static content. But what we want to do is change that dynamic a little bit. We don't want to serve static files. In fact, we want to do dynamic things, and we want to interact with the users and do productive stuff rather than just serving out files. And so that's the main goal of this presentation is how to get our scripts talking to a web server. Right, so some back-end web dev concepts, just to sort of set the stage for the ways in which we'll interact with a web server. So we'll start with HTTP. HTTP is Hypertext Transfer Protocol. It's, most folks know, unencrypted. Its default port is port 80. It speaks TCP. It's a request response protocol. And all that really means is just the client, the browser, sends a request, and the browser responds in a tit-for-tat kind of way, just request response. And that's all HTTP really is. There are extensions for long-lived connections, et cetera, but for this presentation, we're just dealing with request response. The browser sends a request to a URL. And when it does so of a certain type or method in HTTP parlance. And by default, that's the GET method. Every request is or should be followed up with a server reply with status code. So you've probably seen these. A 200 status code is OK, or a 404 status code is not found. Requests and responses can each have headers and data. So we don't often see requests have data, although it is supported. Kind of like this. So we've got a request and a response here. And this is all based around the URL in red at the top there. So the first line, in the green box on the top, the first line is the request line. And so this has the very first word, the get there. That's the HTTP method, followed by the URL fragment, and then followed by the HTTP version, which is pretty much HTTP 1.1 these days. That's what it always is. That's the request line. So that's where the server knows where to send the request. In this example, it's an HTML file. But in a dynamic sense, that might not be true. But for this particular example, that's true. Below the request line are the various headers. These are HTTP headers. So the host : and then the name of the website. That corresponds to the URL. The browser hands that over to the web server. So everything in the request, the top green box, is all data that the browser has sent to the web server. And then it has various parameters for how it would like to accept data. So it can accept images, and at the end it can accept everything. It's kind of redundant. The language, if it needs to be encoded or compressed in any way, it supports those. The browser will hand off the version of the browser to the server in just about every case. That's a simplified user agent string. And in this case, which is a little non-standard for a GET request, there is actually a body, which is below the blank line in the request. That's not typical for a GET request, for what it's worth. But that is supported. Down below, once the request is sent to the server will give a response. And this is what the format of a response looks like. So it starts with the HTTP version again, the status code, in this case a 200 OK, it's a thumbs up there, and then a bunch of headers as well. So the date is just the current date of the server line is just some version information on the server. Last modified is the modification date of the resource. This is important. I don't know how many folks use auto-package, but this could be quite important for tracking when something needs to be downloaded or not. And the same with an e-tag. It's just kind of a hash for the modification date and the file size and stuff like that. And there's other stuff that describes the returned content, like the length and the content type. In this case, there's a tiny little HTML document that's returned in the response. And that's directly in line in the response, separated by another blank line. So that's called the body. And in this case, it's just a 35 byte HTML document with a 1H1 tag in it. And that's a complete round trip in HTTP. Just wanted to lay out the various bits of a typical HTTP request and response there. This will be important when we get to interpreting things like headers and such a little later. So query strings. HTTP query strings are, I know you've seen them, they're everything past the question mark in a URL. And so this ends up essentially being arbitrary data, although there's some very well accepted formats of what it looks like, and you've probably seen it. It's this key value association, a string equals a string, or key equals value. And you can combine them by adding an ampersand, and you can get multiples of these key value pairs, essentially, that you can pass to the URL. Now, what's important about this is it's arbitrary and disconnected from the URL. So if you have a path on the URL, you don't have to have a corresponding file system script or something that corresponds to each of those. You just tack on the end of it, and that will get handed to the resource. If it's just a file, Typically, most web servers just ignore it, but it comes in particularly handy for scripting and things like that. This key value combined by ampersands and equal signs, it's sometimes called form encoded, and that's just because it's similar to how forms are submitted, HTML forms. But we'll talk about that in a bit. And something I know you're all familiar with is HTML and CSS. It's hierarchical data represented as the document object model. We don't have to talk about too much of this because, like I said, I assume that most folks have right-clicked on a web page before and viewed source. So, as I said before, it's often served just from a file on a web server, but we don't want to do that. We want to dynamically generate that based on input and things. CSS describes style of documents, color, spacing, fonts, etc. You could do your own styles, but if you're like me and you have no design sense, you just use Bootstrap. Okay. So HTML forms. Everyone's interacted with an HTML form. They're just they're typical operating system input widgets, but on a web page. So checkboxes and radio buttons and text input boxes and drop downs, etc. So those are generated with special HTML elements, such as input and select and text area. And having those elements on the page will render the HTML element on the page, much like that example in the upper right there. So the data from the forms, as I said, is typically submitted using the form encoding. Most web scripting, you won't really have to deal with how this stuff is encoded. But I mentioned it, especially for our first example case. You kind of do have to pay attention to that. But most of the time you won't, because the libraries will abstract all that away, and you can just say, give me this variable, and they'll kind of do the magic of all the parsing without having to worry about it. And just a quick mention as well, client-side web scripting, code that runs in your browser, JavaScript. Sure, you're quite familiar with it. It's not as sucky as it used to be. Lots of people had a really bad opinion about JavaScript in general. I think that's because people were generally abusing it. But it's much better now with things like jQuery and recent frameworks and Node and NPM and all that fun stuff. Lots of good time savers as well. You can either embed the JavaScript directly into HTML tags, or you can link it from HTML. This comes in particular handy when you're starting to get to a larger application and you've got too much JavaScript in one file. You can break that out into separate files. And obviously it allows for rich interactivity, complex logic. It really is a full programming language in the browser, which is quite handy. We won't really be talking about any of this today, but I mention it just as an aside. And another quick mention is Ajax. So when I started talking about this, I said, generally people go to the address bar to type in a URL, or they'll follow a link, or they'll type in a search engine. And so that's generally, or they'll push a button on an HTML form. And that's the way that people will generally get the browser to send another request to the client. But that's not the only way that it has to be done. For example, if you wanted to put that action on a timer, you could certainly do that with JavaScript. And then with Ajax, which is asynchronous JavaScript and XML, in that timer, you can say, contact the server without a page refresh. So this is pretty handy because you don't have to wait for the user to do something, or you don't have to depend on the typical ways that a page gets refreshed. You can fetch data and send data to a server whenever you want or however you want. So I just mentioned that as another thing in the toolbox for web UI interaction. Okay, putting it together, web stacks. So this is kind of a big, ambiguous, amorphous kind of topic that people have lots of opinions on and how things go together, but I'm hoping to just kind of give you an overview of some high-level concepts of it. Generally speaking, and certainly germane to this particular presentation, there's a couple of really big pieces that are key to making things talk to each other. So we've got the web server that we've talked about. Apache's a popular one. Nginx is another popular one. And then we've got middleware, which is this sort of generic, open-ended name for a whole bunch of connecting technologies. If you've ever used PHP before, you're probably familiar with mod_PHP for Apache. If you've ever used CGI, you're probably familiar with mod CGI and all the various options. And then there's others like fast CGI and Unicorn and GUnicorn and mod Perl, back when Perl used to be cool for web programming, and WSGI if you're a Python developer. And so I'll go into each of these in depth in a bit, but middleware is kind of ill-defined, but it's what enables the web server to talk to our code. Okay, so now down below there's optional web framework. I think this is something worthwhile to mention because if you're dealing directly with the output and input to a web server, it gets very raw and tedious and error-prone. And web frameworks really help whisk away all that nonsense and allow you to be efficient with web scripts. So things like Flask or Cake PHP, if you're a PHP developer, Django, etc. Those web frameworks help a lot to really improve the efficiency when you sit down to make something happen. They've got all these abstractions that are great. And then, of course, the scripts and tools, the thing that you actually want to do, the code that does the stuff. That can be directly connected to the middleware, or you can run it through a framework, however you like. But yeah, that's the important part. Yeah. Other people consider other layers when they typically talk about backends, like they'll consider the browser a layer, especially if you've got client-side code in there. That's often talked about. The server OS comes into play a lot. We won't really be talking about that because we're a bit higher level than that at the moment. Lots of these web frameworks will have database abstractions and object relational mapping and all sorts of fun stuff, which is really neat if you're into connecting your stuff to databases. We won't be doing that today. I just want to mention it for posterity. So some web backends actually combine all of these layers. Like Node.js, it's a web server. It connects the web server to its own framework, and your code plugs into it. It does all three. It does all of these things. So you can actually point a client directly at it, which is quite nice because that saves a lot of time. Other projects can kind of go both ways. For example, Flask and Bottle 2 has its own development web server that is recommended to not be used in production, but works great. And especially when you're bringing up some new piece of code, not having to deal with a web server is quite valuable because configuring the web server and getting the middleware to talk to your code and permissions and all of this wonky stuff that gets in the way sometimes just slows you down, and you just want to code. Darn it! And so some of these things just kind of wipe away that mess, at least in the temporary. If you go to post 1,000 hits a minute or something like that, you probably won't be able to get away with the development server. But I mention it to save time. Okay, so the web server. Again, Apache, Nginx are popular. Apache's nice. Every OS X computer has come with Apache since the time of the dinosaurs. HTTP protocol server. That's the primary duty of a web server, right? So it handles the low-level network communication directly with the browser. It can do higher level things, which is really nice. It can abstract the higher level things like SSL. You can just configure your web server to do that stuff, and then your code doesn't have to worry about it. Same with authentication, same with access control. It can do those. Usually, as said before, usually just reads static files in a path and delivers them to the browser. But of course, what we really care about here is the scripting and dynamic support. In other words, its ability to connect to middleware. So, as I said, middleware is the amorphous, the ill-defined thing, and it's kind of all over the place. And each piece of middleware has its own peculiarities and how it works and how it deals with the various bits of HTTP, like headers and input data and all that stuff, is just slightly different for all of them. And yeah, so but it's the glue that connects the web server to our dynamic content. A couple of patterns that are kind of are they can be built into the web server. So as I said before, if you're familiar with PHP, the PHP interpreter is actually built into a module that runs in Apache. So it's directly built into the web server. I still think it qualifies as middleware because it doesn't directly have to do with anything with HTTP per se. But nonetheless, it's built into the web server. And there are others, ModPython, Unicorn, Node, etc., kind of do the same thing. But the other way is that you call out to something else. So your web server says, okay, I can't do that, or it well knows that it doesn't do that, and says there's something better that can handle that. So it needs to start another process, or open a connection to a socket or a socket file, or connect to another server that's running say the fast CGI protocol, or just straight up proxying HTTP to another server. And so those are other types of middleware. And then the receiving end of that middleware has to talk the same language, for example, fast CGI. But that's the other pattern that web servers can use to talk to their middleware. Is they call out, they communicate outside the web server through some IPC, some interprocess communication method. And I just want to talk about web frameworks a little bit. So there's a ton of them. Everyone has their favorite, and everyone has an opinion. But the nice thing about them is, as I said before, they abstract away or provide helpers for the gritty details of HTTP, URLs, headers, HTML forms, encodings, all that mess, which can get quite complicated in HTTP. But being able to not have to think about those and instead think about the thing that you want your code to do is really good. Allows you to be more productive on your code rather than details of how HTTP works, which is good. Obviously, they can add complexity and dependencies, which can be bad, right? It's one more thing that can break. Some frameworks go all out, and they're often called MVC frameworks. I'm thinking of things like Django, where they do a lot of the thinking and decision making for you in exchange for you don't have to think about those aspects that they've already thought about. So they constrain the way that you put you form your requests. They constrain the way you talk to the database. And maybe constrain is the wrong word, but they try and make those decisions for you, so you can just get to the part where your code does its thing. And the MVC, for those who don't know, is Model View Controller. Go ahead and read up on it, but model is basically data. Usually it has to deal with databases. The view, obviously, is rendering content and delivering content. And the controller is request routing. It gets vague depending on where your code lives, if it's on the client or in the browser, etc. But some of those large large frameworks do that. I kind of look at it as a trade-off between productivity and flexibility. So if you want to give up a little bit of flexibility to work quickly, especially for a larger project, then you might want to look at one of the bigger frameworks. If you need a bit more flexibility because maybe you're doing something a little non-standard, maybe look at one of the smaller frameworks or micro frameworks as they're sometimes called. Okay, and then finally, scripts and tools. The thing that we want to do, that's what we want to concentrate on. So in general, they only really do three things. They take HTTP input, they perform the thing that needs to be done, probably based on that input, and then they generate output to send back to the browser on what they did or anything that the browser needs to know. How any of the above happens really depends on what language, how it's connected, the middleware, the framework, all that stuff, which is why I wanted to go over some examples and stuff like that. All right. Let's see how the streaming can handle this. So, example one, just want to do a very simple CGI script, which does one thing. It's going to rebuild monkey catalogs for us. So pretend that, say you have a file server, an AFP file server, and you've got your monkey repository on this file server, and a whole bunch of people go and modify the package infos, but no one really wants to SSH into that server or open a terminal or whatever to rebuild the catalog, right? That's just, everyone's too lazy for that. So what can we do? Since it's a pretty simple thing, it's one command, let's make it, let's attach that to a web server so that anyone can just do it on a button press. Just open a browser, push the button, there you go. So in this example, our web server is going to be Apache, and I'll actually demo this right here. And we're going to use CGI as the middleware. And CGI is, if you're not familiar, is a very, very simple protocol. Every time a request goes to a CGI script, it launches a copy of that script for each request, does the processing, returns the data, and then the script exits. And as you can imagine, that's quite inefficient. It doesn't handle concurrency very well. And you can run into race conditions and other things as well. But the one request, or the one new process per request model is pretty terrible. So generally CGI is not very often used. It's not very flexible. But I do want to show you guys this because it's also one of like the most easiest things to do with pretty much any web browser. If you just need to get a quick script up there running based off a web server, CGI might be the thing that saves the day for that in a pinch moment. And then finally, just want to say this is an illustrative example. Nobody should ever use Bash for CGI because it's painful and it makes your eyes bleed, and you don't want to do that. But it's, like I said, it's just illustrative. Okay. Give me a second here as I exit the presentation here. Okay, so I've got my machine here, and feel free to follow along if you've got the prep steps. Some of those steps I'll have to do myself here as well. They're pretty quick, yeah. So okay, so I want to first of all make sure Apache is running on my computer, and to do that, I'm just going to run Apache control, which is the standard Apache controller utility. And just do start. I don't have to enter my password here. So operation already in progress. So for me, Apache is already started. So that should mean that I should be able to open my browser here. And go to localhost. And hurrah, it works. So that's good. It's serving static content. If I go to the root of my web server documents, then what we'll find here is a little HTML document that was just served. And so all it's doing is reading that file and handing it back to the browser with a little extra data. Okay, so what we want to do then is get some dynamic content, and to do that, we're going to use CGI. So we need to make sure that that CGI is enabled, and in Yosemite, that was actually disabled in the default configuration. So we're going to edit the Apache configuration file. Hopefully, you guys can see that. Let me know if the text is too small or whatever. So this is the big long Apache configuration file, and I'm going to look for the mod CGI line. So here the CGI module is actually disabled because it has a hash in front of it. It's commented out. So I'm going to uncomment it, and I forgot to edit this file as root, so I'm going to sudo edit that. Find that line again, which for me is line number 131. Uncomment, I'm sorry, line 157. Uncomment the CGI module, save that file, and restart Apache. So again, that's the Apache control, and it has a command called graceful, which gracefully restarts the server. So it has. Now CGI should be started and going. The place where CGI documents live on OS 10 is library web server CGI executables. I think by default it's empty. So I'm going to copy a couple things in there. Well, one thing you'll notice, my username is present, and I changed the permissions on this folder, the CGI executable folder, just so I could find or copy some things in here rather than having to do everything on the terminal. And so the instructions how to change those permissions are in that preparation document. But I'm going to copy a couple of shell scripts in here. This code, by the way, is on the GitHub for the presentation. This is demo 1, so it's these 4 shell script files here. And we'll take a closer look at those in a sec. So I put these 4 shell scripts here, and I'm going to check them to make sure they're executable. They are, so they all have the execute bits, but just because I'm paranoid, I'm going to make them all executable anyway. CGI scripts are executed as binaries, so the CGI module of Apache looks for files in a specific place and sees if there's an executable file and then executes it, so it needs to have the execute permissions. Okay, so the default CGI path is CGI bin, which corresponds to this path here, the library web server CGI executables. The Apache configuration file says so. So we should be able to just go rebuild1.sh, and there we go. So it just executed rebuild1.sh, which is what I went to. And let me show you that script. So this is the CGI script that generates this content here. So as we saw in the request slide, this is generating a server response, and this is how CGI works. It just outputs the raw content in the form of everything below the status line. And so that's it right there. So it says it has one header of content type, text HTML, and then delivers some HTML of HTML body hello world. And if we show page source, that's what it is. But notably, it's not just a file. It actually generated that, right? We can run this shell script on the command line, and it'll do the same thing. It's a normal executable shell script, so that's pretty handy. And we can attach anything to that. So let's go a little further. So this is rebuild2.sh. And what it does is it prints the environment variables of the server. Of the CGI process that executed from the web server. And this is really handy because this tells us all of the variables that the web server handed off to us. And in CGI, all the headers that were delivered to us from the client are handed off to our CGI script by these HTTP underscore variables. So the host, which matches my browser URL, was handed off to us in the headers. And the connection keep alive was as well, and all of these were, except language, except encoding, etc. Another important one in here is the query string, which is empty, but it's in there as well. There's a couple of server-only variables that only the server knows, so it hands those off, like server address and gateway interface, etc., and server protocol. Those are just things that the server is telling you to set some context for you. Here's the user agent. So here's my Safari browser handing that information off to my CGI script through Apache. So if we wanted, we could base decisions off of that data. We could say if this is a Safari browser, do something. If it's a Chrome browser, do something else. So this is the basis of getting input from the web browser all the way to your script so that we can make decisions. Okay, so let's take it a little bit further. Now we have a button, and this code is here. It's just the HTML that generates the button. So it's the form element which defines a form, and anyone who's done HTML coding before sees a quite egregious error. I have two form tags in here when it should be closing the above form tag. So let me just fix that. But in between the form tags is the opening form tag and the closing form tag is an input, which is what generates the button. That's all this thing does. It's just a button. It doesn't actually do anything yet. But wanted to show the dynamic generation of forms. Okay, and then finally, let's do our final script. So we modified this guy to be this script, and so what it says is if our I suppose I didn't quite show that. So in this rebuild script here, by default, it has no query string. So everything past the question mark. So it has no query string. But when you click the button, because we told it that the form is a get, it has submitted or made another request with that data appended as the query string. And here we have input equals make catalogs. So this is a way that we can tell that the button's been pressed versus if it hasn't been pressed. So when you just arrive, we don't have to do anything because we don't want to do anything yet. We want to make it explicit. We want to make the user actually click the button to do something. And so when they click the button, it's a different request to the browser, which actually shows up in our environment variables. And I'll demonstrate this here. This might be a bit small. So the query string is input equals make catalogs, and down here, query string is input equals make catalogs. So we can see that our CGI script has access to the query string, and just like this script here, rebuild 4, it's actually going to make a decision. It's going to say if the query string equals input equals make catalogs, then rebuild the catalogs. And this is done. This is just if you're not familiar with Monkey, no worries. This is just a command that rebuilds the Monkey catalogs. But it could be anything. It could be arm-rf star, whatever you want. So users, for this specific example, I think I need to change this path, and you may as well. Because my particular path for my example monkey configuration is different than, let me just verify that quickly, sorry. Yeah, okay. So it is in that alternate path. So, okay, so now if I go to 4, so I'm going to hit the button now, and because it changed the query string, my script was able to see that, yes, my query string equals that, so we're going to actually run that. And because of the way CGI scripts work, it just outputs anything that's output just goes to the browser. So this here is the output of make catalogs, and that allows make catalogs to run. So it runs and spits its output to the CGI script, which then gets handed off to the browser. So there we go. So we made server-side command line work based off an HTML button, and that's pretty straightforward. It's not ideal. It's a CGI script. It's a bash script, but it does work. Okay. So that's the end of example 1. I don't know if you were able to follow along, but do try this if you're curious. It's just a CGI script. It's ancient, but if you just need that quick web UI, sometimes you can just mock it up with CGI script and away you go. All right. So my second example is going to be the same thing, but implemented in PHP, just to show a different way of how the web server talks with the middleware and deals with the input variables and stuff like that. I assume a number of you have probably played with PHP, so this will probably be a little more familiar. And hopefully I can compare and contrast a little bit between CGI. Okay. So by default, PHP is off in Apache, so we have to go modify that. It's PHP 5 in Yosemite. I think it has been for a while. Line 169 for me, so I'm going to uncomment that. And all the other supporting code is already, or configuration is already in Apache. So much like CGI, there is provision for CGI already in the configuration file. Just the module was disabled, and that's the same for PHP 5. So I'm going to re-enable it there. Give it a graceful restart to reload its configuration. And I'm going to go back to my, thanks Safari, that's exactly what I wanted. Okay, so back to my 127001. This is, again, my library documents folder here. And there's a quick PHP, for those of you who've done PHP, you probably know the PHP info trick, just to make sure PHP is working. So create this PHP info file, and this allows us to verify that PHP is working. We're running 557 and a whole bunch of options and stuff. So that means that Apache has correctly interpreted my .php file as a real PHP file and interprets it, and the PHP info function inside that PHP info file actually just spits out this large configuration data thing, and that lets me know, great, Apache's talking to PHP, and we can put code in there. So also in the demo code, this is demo 2. So we have a rebuild.php, which I'll open here. And so this looks much different than the CGI script that does the same thing, but it's the same functionality. So all it is here's our HTML tags, here's our forms, and look, I did this error again. I must have copied and pasted. It's terrible. But it's the same HTML. The form is there, the input is there, And the same conditional that tests whether there's something on the query string is also there. In this case, though, PHP has interpreted and parsed the query string for me. So all I have to do is test whether there's an array dictionary key that is input, and if it matches, make catalogs. And if it does, then run my system command. Which is the same thing. It's just make catalogs at the specified place. But it's PHP, and I wanted to call out the differences in the way that it interprets the various query strings and things like that. It has helper functions to get HTTP headers as well, and they'll escape things like uppercase and lowercase for you, etc. But it's the same thing. This just happens to reverse whereas in a shell script, you start with a shell script. In PHP, you get to start with just putting in HTML code, unless you have special options turned on. So it's the same thing, PHP, but it's built into Apache, so it doesn't have to call another process. It can be quite a bit more efficient, but otherwise it's the same functionality. Okay, so that is example number 2. Is there any questions, or is everything going good? Can I clarify anything or anything?
Any questions?
I got one more example, and then.
Those run as root.
What was that?
Do those run as root?
Do those run as root, Jesse?
Sorry, I didn't catch that.
Do those run as root?
Oh, the web servers. Yes, most web servers will run as root, however, they'll often after they. Right, so it's kind of a trick question, right? Web servers will start out as root because they need to listen on privileged ports like port 80, port 443. But they'll often, as soon as they grab those privileged resources, they'll change their own ownership to be run as the web user specified. For Apache, this is the www user. And in fact, we can see this if we look at our activity monitor. Yes, I need to look at all processes, don't I? These 3 processes are the Apache web server. It's traditionally called the HTTPD web server, even though it is Apache. But here we can see the user is _www, which is what the requests come in as, and then root handles, and then the one process, the master daemon, that handles all the privileged stuff. So I guess in Apache's case, it runs as both an unprivileged user and a privileged user. But that brings up a really good point. The CGI scripts will run as the web server user. And this is the case with PHP as well. So if you have something that needs to do something as root on the web server, right, you have some piece of code, you're going to have to squirrel around that. One potential is to use shell out to another shell script that's included in like your sudoers file. That's a strategy. Probably wouldn't recommend that. Another one is to just please try not to have anything run root from a web server. Just all kinds of dangerous. In the other forms of pull up the slide here. In the other forms of right. So when you call out to another process type method, like the CGI and the fast CGI especially, things that need to connect to another running server process, those can run as different users. They don't all have to run as the same www user. They can run as whatever you want, as long as they can talk to each other on whatever method they talk to each other. So if it's a sockets file, obviously they each have to be able to read and write that file. If it's a TCP socket, they each have to be able to open that socket and write to it, etc. So yeah, you can have bits and pieces that run as different users on the system by using different types of middleware. Okay, so finally, I'll do the last demo, which is completely different than the others, and then we can do some general Q&A, I suppose. So in this case, I'm going to use Flask, and Flask has a development server, and so it actually does all of the things. It does the middleware, it does the web server, and if you do Python development, you probably have heard about WSGI, which is Python's own version of web middleware. So the stack, if you actually look at the middleware, goes web server, then like if you were typically going to set this up, then it would go, say, FastCGI, and then FastCGI would get adapted to WSGI, and WSGI would get adapted to the Flask application, finally making its way down to your code. So some of these things get quite complex. But in this case, Flask has a development server that folds all that into one thing, so you don't have to worry about it. So I want to show you that now. Okay, so I'm going to make a virtual environment because I like to install my Python modules in virtual environments. I don't have to bother my system libraries. So that created the virtual environment. Now I'm going to activate it, which is all sort of parlance of virtual environment. Then I'm going to pip install Flask, which just goes to the web and installs all the dependencies and things. Okay, so now my virtual environment, my Python virtual environment has Flask installed. And what I'm going to do is change directory into, and I'm just going to serve this directly out of the code that's in the GitHub repository once you have a virtual environment. So Python, let's take a look at this code first. So it's pretty simple. Flask and all this is documented in Flask documentation, but you just start the application and it says running a server on port 5000, which is its default. So it's just a web server. So now I can just connect to that web server at that location. And there it is. Because I started this out of my session, this particular web server runs as my user. And it's on a non-privileged port, so it can happily open that port way up there in the 5,000 range. And it shows my connection logs. So this is great. It just started an ad hoc web server for me with all the libraries loaded, everything I need, and I can just start writing Python code. I don't even have to worry about it. If you've this is a pattern I've used before. If you've ever used Margarita, for example, it uses this development web server by default. So here's the code for Flask. Yes, it's a bit more complicated, but I think that's justified, especially if your application gets larger than pushing a single button on a web page. But it does the same exact thing. So it has an application routing mechanism called root, and that just maps this function with this Python decorator. And it does the same thing. So it looks at the query string. The request.args represents the parsed query string. It gets the rebuild variable, checks to see if it's the make catalogs, and then does the slightly more verbose Python version of launching that same command, the make catalogs. And in this case, though, the prime difference is you don't see any HTML code in here. And that's because I wanted to introduce the concept of templates. So when you mix, sorry PHP, but when you mix your HTML with your logic, everything just gets super messy, I find. And so I prefer to have those things completely separate, right? All your markup and styles and all that stuff ought to be separate from your logic and your code. So says I anyway. And so that's what I've done here. So here we've got this render template that calls out to this hello.html file, and this is just a part of Flask. It works this template format, which is nice. Hey, look, I didn't actually make that mistake this time. 1 out of 3. But you also notice that it does have a little bit of logic, right? This template needs to know if we actually ran the command or not. Is there any output? output the output. It's a shorthand for output the output variable. And so it does the same thing, prints a horizontal rule, and then pre-formats the output. But it's nice and compact. There's nothing mixed in here that has to do with making a catalog or looking at a query string or anything like that. It's just purely layout logic, right? So that's a nice separation of duties there. Yeah. So that's it. That's Flask. It's got its own. It has the capability to have its own web server. It has its own methodology of working with all the various bits of query strings. And I know I focused on query strings. Didn't really touch on headers or anything like that with any other framework. But I really just wanted to establish that getting started with this stuff is straightforward. Should be pretty quick. And yeah, I hope that was useful to people.
Any other questions for Jesse? No? All right. Thanks, Jesse.
Thank you. Thank you. Later.
All right. So we're going to give James a second to get set up here. So feel free to refill your drink if you need to.
There's a go in the shirt contest.
actually currently now focusing on information tools, which is basically we do a lot of fun stuff. They basically made very easy. So we currently have an Facebook. So I can say, any of my clients is the console manager in this Facebook group, and if so, what packages or configurations collectively
For them, they're small.
joining this group. Now, by default, know where to go. Is there a Slack
All right, I think we're ready to go. If you want to take it away, James.
Hello, everyone. My name is James. Hello. I know a lot of you. I work at the pin factory. My name is James Barclay. It's where all the pins are made. So yeah, today I'm going to talk about working with system frameworks in Python and Objective-C. The presentation was given at Penn State University Mac Admins Conference, and you can view the YouTube video using this link. So if you miss anything during this presentation, feel free to go back and take a look there. I also made an attempt to summarize the week at Penn State in a series of emoticons. And a friend of mine, Elliot Jordan, pointed out today that there was almost nothing to do with technology in there, so I just inserted the Apple logo. So before we get any further, I wanted to give you a link to where the source code for the Python demo and the Objective-C demo is, and as also the slides will be available on GitHub. So it's just github.com/futureimperfect/PSU PyObc demo, and then there's another one for Objective-C, which is just PSU demo. And there's the obligatory animation. So as for the agenda, we'll first start by talking about what a system framework is, why you should care. Then we'll do a really brief overview of the frameworks and the APIs and classes that will be demonstrated in both Python and Objective-C. And then we'll do one demo in Python first, and then Objective-C. And then we'll have a wrap up and questions. So what is a system framework? According to Apple, it is something that provides the interfaces that you need to write software for the Mac. So if you're going to be writing a script or a GUI application or a more advanced command line tool, it helps to have some familiarity with these APIs. And I think most importantly, knowing about these will teach you more about the system that you are supporting, which ultimately will make you probably better at your job. So it helps. And here's just a quick overview of some of the technologies that we'll be covering. First up, we'll have, under the Foundation umbrella, we have NS File Manager, NS Task, NS URL Session, NS User Defaults. NS File Manager will allow us to do things like create, read, update, delete operations on the file system. NS Task will allow us to spawn a sub-process from your main application. So if you wanted to do something like create a graphical interface for a command line tool, that might be useful. NS URL Session allows you to download things from the web. NS User Defaults allows you to work with the default system on OS X. So if you're familiar with working with the command line defaults, this is our programmatic interface to that. And then just briefly touch on NS Application, which is manages like the event loop and a lot of other things in Cocoa. Core Foundation, which is a lower level. And CF preferences. And then we'll just really quickly touch on core graphics and quartz, which are often used synonymously. And then before we jump into the Python demo, I just wanted to make a quick remark about PyObc or Python Objective-C. I think overall, it's, it has its ups and downs. Some of those that I've noticed working with it is that, first of all, Python is probably easier to pick up than Objective-C in most cases. And if you're already familiar with Python, it allows you to take advantage of the system frameworks that are available to you on OS X. In terms of the cons, I think the community is smaller. So if you're looking for an answer on Stack Overflow or something, you might not find it. In many cases, you'll find an answer that involves working with Objective-C, and you can kind of piece together most of it because it's pretty similar if you're working with the bridge. And it also can be a little awkward to use. In this case here, I have an example of an Objective-C method call over here. So if we have like a mycar object and we call refuel with, the refuel with method, and we pass it the pass gas, and then replace cap, and then pass it a Boolean. So in Python or in PyObc, if we were to call that same method, it would be mycar.refuel with, and replace it with the colon with the underscore there, and then replace cap, another underscore, and then you pass the parameters within the parentheses. It's a little more awkward to use, and it doesn't read quite the same. So a lot of people, you'll hear people say that Objective-C is very expressive, and you don't get that necessarily with a lot of other languages. All right, so first demo is in Python. So I'm just going to go over a few example functions that demonstrate how to work with some of these APIs through Python. So the first one here is just a function, we'll call it isComputerLocked. And then you can imagine further up here, we've like imported quartz, so do like a line that just says import quartz. And then we can just create a dictionary and then call quartz.cgsession copy current dictionary. And then we'll get a native Python dictionary. And if we call on that object cgsession on console key, and then if you ask if that's false, this is just getting the value from the dictionary. And then we have also here, cgsession screen is locked. This would mean that the computer is locked. So if you were to run this code on a computer like over SSH or something like that, and it was locked, it would return true. Otherwise, it would return false. So that could be useful if you are, you need to run a script or something on a client machine, and you only want it to happen if someone's logged in, or vice versa. Another example here, NS Workspace and NS Application. So these two example functions, the first one will block the user. I call it block user, but what it's doing is creating calling the NS Workspace shared workspace. We're creating an object there, and then we call the hide other applications method on that object, and that will do just what it says. So like if you need a script to hide all other applications and only show your UI, those two lines of code for you. And then here we have a bit mask that I've created. So options, we're just calling it options. So this does a bitwise OR with these options here, which are part of like the kiosk mode APIs. So we have NS application presentation hide doc, and then disable process switching, disable force quit, disable session termination, and there are many more. Those are all available on Apple's developer site. And then if we just call on our NS app, the set presentation options, and then pass the options, it will do exactly what it says there. And conversely, if we wanted to unblock a user, we would just call or create the NS application presentation default options, and then just, again, call presentation options. So you could really piss off your users if you wanted to, or do something more useful. This one is probably pretty handy for a lot of Mac admins. CF preferences allows you to work with the preferences system on OS X and iOS. But here we have a function called getPrefVal, and we just pass it the key and the domain. So the domain would be like com.apple.safari, and then a key could be, I don't know, name some Safari preference that exists. And that will return the value. And this is a safe way to do that as opposed to like just reading from the plist. Similar to like how you would, maybe using the defaults is safe from like preference caching or aggressive preference caching. This is also safe from that. And then set pref val would do, you pass it similar parameters, but you also include the data. So if you have a Boolean or a dictionary or an array, and you want to write that data to a preference domain, you could do that here. I'm sure a lot of you have tried, setting complex or something more than just like a Boolean or a string for a preference with defaults. It gets kind of unwieldy. This is probably easier, and it's not very many lines of code. CF preferences app values forced. This is something that is available for determining whether a particular application preference is being managed through MCX or a profile. So for instance here, if we call that function and ask for password, and then the domain, which is com.apple.screensaver, that will return true or false, depending on whether that application is being managed. NS Workspace, this is another fun one. If we just create an NS Workspace shared workspace object, we can call the running applications method on that object, and then get a list of all the applications on a particular machine. So instead of like trying to parse like PS output or whatever, this might be useful. Okay, so here's just a quick overview of a script that I wrote that uses PyObc, and it uses a lot of the example functions that we just touched on. So one of the things it does, it just hides all of the other applications. If I go back there, I can see we'll scroll up here in the video. If I wanted to get a list of the Finder sidebar items, maybe modify them, who knows. Test if the computer is locked. Check if ask for password preference is being managed. Get a list of all the running apps, so on and so forth. That script is in the PSU PyObc demo repo on GitHub. All right, so that's it for the Python part. So we're going to spend a little more time on the Objective-C demo. So this is just an overview of what we'll be building. So how many people here have ever used Causse or heard of it? Handful? Yeah, Causse. It's fun. So we're going to go over how to build a GUI for Causse. What this application will do is, if you are unfortunate enough to not have Cause, it will allow you to install it. So don't try to install it yet. You can just type in a string and press the Say It button, and it will print the ASCII cow, which would be the output from the Cause command. And it will also say whatever you typed in there using whatever voice you specify. So I sped this up significantly, but this is all on GitHub. But this is like the boring part, like designing the UI. It's not a great UI, so I don't think we need to spend a lot of time on it. Basically, we've just possibly.
You want to take this one?
Sure. Yeah, so we've created a new Xcode project, gone to the main menu.nib file, and just designed a very basic UI. So you drag in buttons and labels and so on and so forth, make it look however you want. Didn't do anything with like constraints or anything. So it's a pretty basic UI, but you can make it whatever you want. So now that we've now that we've created the UI, what we'll do is wire up your interface so that the interface that we've will be addressable in our code. So we'll here create an outlet for Cause installed label, which is that the label in the UI that just says Cause is not installed. So when it is installed, we'll want to change that, of course. We'll also create an outlet for the progress indicator. When we're Cause utility, it will spin. Yeah. Okay. All right. And then additionally, we'll create an outlet for the image view, which is that little green or red jelly bean that you sometimes see in user interfaces. So in the case where where Cause is installed, you would set that to green, otherwise red. And install Cause button. The reason we're creating an outlet for that in the UI here is that once we've installed it, we don't want that button to be enabled. We don't want people reinstalling it over and over again. And then an outlet for what should the cow say, which is the text field here. And the reason we need that is because when somebody types something in there, we want to be able to get that value and then do something with it, like run the cow say command and get the data back, or say that using the system voice. And the say it button here, an outlet is created for that, because if we don't have cow say installed, we don't want to be able to click that and do anything, right? And then you'll see here also there's the text view. We're creating an outlet for that just by, and sorry, I didn't touch on this, but like to create the outlet, what you do is select the element in the interface, and if you just option on your the header file, then that will bring up the assistant editor, and then you can just control drag these over, and that will create the properties for you. And also an instance variable that you can reference in your code. So then, yeah, I've created an outlet for the text view there. And then here what I'm doing is I'm using Cocoa bindings, which is going to save us from having to write a lot of glue code. So we're taking this text box, and then if I just go to the value here in the Cocoa bindings tab, and then just bind that to an arbitrary string, and then check the box to continuously update the value, what that will do is it'll save it in the preference domain. So like if this, we called it com dot, cowsay dot whatever, that will save whatever, the value of that text field in the string that you specify. And then I also created one there for the say it button, but not binding the value. I bound the enabled key so that if there was nothing in this text field, then don't make the button enabled. So like you don't even need to write code for that. Like you literally just click buttons in the UI. It's nice. Okay. Checking if cowsay is installed. Now we're at the appdelegate.m file that's created automatically when you create a new Xcode project. I'm just creating a string constant, and we're calling it the cow herself, which is just going to be the string, the cow herself. And we'll use, the reason I'm doing this is just so I don't like have a typo in my code if I'm trying to pass that string to a bunch of different places, and it's nice to not have to worry about that. And you get autocomplete, which is great. So we're creating a method here called check for cowsay, and we're using the void return type because it doesn't need to return anything. And then we're creating an NS file manager object, and then we'll create a string, which is the path to the cowsay executable. And as I mentioned earlier, the NS file manager allows you to do like the create, read, update, delete operations on the file system, among other things. So if we call this FM, which is our NS file manager object, and then we run the method is executable file at path, and then pass it our string, it will return true if there's an executable there. Otherwise, it won't. So what we're doing here is saying property that we created through Interface Builder, the cowsay installed status indicator, we can reference that and say, set the image to this image here, which is status available, which is green light. And then you would set the string value of the cowsay installed label that we created to cowsay is installed instead of cowsay is not installed. And then this install cowsay button, we're going to set that to disabled. Otherwise, we'll set the say it button to enabled, so that if you don't have that command line tool there, it won't allow you to run that say it button or click it. So you'll see here, I went back up to the application did finish launching method, which is there by default. And I'm going to run self check for cowsay, which is that instance method that we just created. So immediately after the application launches, it's going to check if that is installed. And then we're also using NS user defaults to see if they're in a cow saved. So basically, when I type the text into the text field and click the say it button, it'll create the cow. But we don't want to lose our work when we quit, so it'll bring it back. The application should terminate method. This is called before the application will terminate. So you can intervene here. In this case, we want to let people know that they're making a mistake by quitting this application. So we're going to make an obnoxious alert. And we'll say here, I think, are you sure you want to quit cowsayer? Yeah, okay. I think we'll change their mind. Set informative text. So like the top one is the bold title, right? And then below that is the informative text. So if you've worked with like Cocoa dialog or something, this is in Cocoa parlance or Objective-C. This is how you do that. And they're probably using this behind the scenes. And then set informative text, life without it. And then right here, if we say if the alert run modal method returns the second button, because we created it like we created the OK button and then the cancel button, we return ns terminate cancel. And that, like, if we look at the method here, it's that what it returns is ns application termination or terminate reply. So that will cancel the application from quitting. Otherwise, terminate immediately. So the next thing we'll create is a class to unzip the Causse source code from GitHub, and then so we'll call it Causse unzipper. And this is only going to have one instance method. We'll just call it unzip, and it takes a source and a destination. And rather than using I think there are like zlib or whatever, like there's C APIs you could use to do this, but we're just going to cheat by actually running the unzip command, and then, hoping for the best. And it usually works. Now, a quick aside, if you were like hoping to get an app in the Mac App Store that needed to do that, they're not going to allow it. You can't spawn a sub process, but like for an open source thing, if you're trying to do for this hackathon, like go for it. Again, created an NS file manager object, and then an NS error, and then a Boolean here called isdir. And then we're again using, instead of like the is executable file at path, we'll call file exists at path, and then pass it the destination, and the is directory, which we pass by reference this Boolean here, isdir. And then the two ampersands after, if you've ever coded in shell scripts or whatever, familiar with it, it's a logical and in this case. It's not the same thing as this one ampersand here for the passing the isdir variable by reference. So if there's if the destination is already there, then we're just going to remove it because it's it'll end up being a temporary directory. And once that's completed, we'll use the file manager create directory at path with intermediate directories attributes error method. So what that will do is create the directory. With intermediate directories, is it the equivalent of like makedir-p or whatever? So if you want to create /foo/bar and foo doesn't exist, it'll create foo and bar. And then we're going to create an NS task object here. This is a common pattern. You'll see the class name alloc in it will allocate memory for that object and then initialize it with some value. And then we'll create the arguments, which are what is going to be passed to the, like if you were to run unzip, and then what parameters you're giving it, the source, the destination, flags, so on and so forth. So in this case, we're using -u-d, destination, and then source. And then you set the launch path. In this case, it's going to be user bin unzip. You could set that to user bin or bin sh or user bin python or whatever you want. And then we'll set the current directory to the destination, and then finally set the arguments, launch, and then wait until it exits. So this will block, but that's okay for this. All right, and that's the unzipper class. So this is the next is the installer class. So we're just going to go to File, New File, and just call it Causse installer, and it will just be a subclass of NS object, which is the root class. And this is a little weird, but we're creating like a completion block property. So the reason we're doing this is we want to know once this installer has finished installing the Causse utility, and then at which point we can update the UI. So when it starts, we want to start like spinning the progress indicator. When it finishes or fails, we want to update the little jelly bean to like green or red accordingly. So created that property, and then we're creating an instance method called download and install Causse. And then we'll go to our implementation and then actually implement that method. But first we're going to import the unzipper class, because what this will do, the installer class will be responsible for the whole installation process, and it's going to need to be able to unzip that Causse binary or the script or whatever from that it gets from GitHub. And we just created an instance variable there called complete to make sure that we don't try to like reinstall more than once here. So created an NS string called Causse URL, which is just the GitHub URL that points to the Causse master.zip, which is just going to give you the latest source code in a zip format. And then we're using NS URL session for this. NS URL session is a pretty advanced API, but in this case, all we really need to do is download the file and then write it somewhere in the file system. So we don't need to use a lot of its fancy features like background downloads and all of that, but it is really useful. And then you'll notice here the completion handler. This is this basically what this does is we're passing it executable code that will run once the download has completed. So we'll have the data and the response from the server, and then an error pointer there in case we need to work with that. And then we're just going to create a temporary directory. And then the temp zip path, which is where we want this to download to, is just that temp directory, and we call string by appending string, and pass that causse.zip. So whatever the temporary directory is, which will be some crazy place on the file system, you'll end up with causse.zip appended to that. The temp path, which is just the same thing without the .zip, is what we'll use for actually the destination. So causse.zip will be the source, or just causse will be the destination. And we take the data parameter that was passed like in the completion handler here, and we write it to the file, which is the zip path. And then we create our unzipper object, which we created over here. And then we just unzip our temp zip path to the temp path. So we took the zip, and then we have the same in the same directory, just the same thing without the .zip extension. And then if there's an error, we just log it and return in this case. And then here we have creating a NS string install script path is going to be the temp path, which is the the temporary directory, and inside of that the Causse directory. String by appending path component that will give us a string with whatever and append whatever we pass to this function here, or this method. In this case, it's causse-master/install.sh. And if to figure that out, you would just download the zip file from GitHub. If there's an installer script, see where it is in the repo, and then you could run the script there. And then I've called this method that we actually haven't implemented yet, called install Causse from script, and then we pass it the install script path. So we'll create that now. And this is just going to, again, just use the ns task to run that installer script that is bundled with the Cause installer, or source code, rather. So the arguments that we're passing to that shell script to install Cause is the path, which we've passed in up here from, when we called install Cause from script. And then I think that particular shell script to install Cause, if you pass it a path, like prefix, it will put it inside of the bin directory of whatever path you give it. So in this case, if we pass user local, it'll create a directory if it's not there and put Cause in the bin directory. And we call set arguments and then set the current directory. So if I guess a lot of you probably worked with like launch daemons or something a script that needs, in order for it to work, needs to be in a particular directory. You can do that with ns task. Just call the set current directory path, and then you pass it a string, and it will run whatever task you've passed it from that particular directory. And this is kind of cool. So like here we're saying there's a termination status method on our task, which is the same thing you would get from a shell script, 0, 1, or whatever. If it's 0, so if it didn't fail, then we'll call install did complete with success and then pass it true or yes. Otherwise, call the same thing but pass it no. So we'll implement that method now, and it's just going to take a Boolean, and we'll call that success. So what we'll do here is say if installed, that instance variable exists and we haven't completed the process, we'll set complete to true so we don't run it again, and then call this the installed success block, completion block property, and pass it the success parameter, which would be either true or false. So that'll go, when we go back to the opt delegate, we'll be able to see what that does. Okay, so now we'll go back to the app delegate implementation file, and we'll implement the installation part. So we've got all we've laid the groundwork in terms of like getting the unzipper class created and the installer class created. So now we can go back to our IB action, which so when you are in interface builder, if you control drag over, and if instead of using outlet you choose action, what this will, it'll create an instance method in whatever file you set to or wherever you created that property, or I'm sorry, the action there, and then whenever that button is clicked, this code executes. So like in this case, we're going to create a Cause installer object, and then, which is that class we just created. And then in terms of updating the UI, we set the status indicator to hidden. So that green or red jelly bean, we hide it. And then we show the progress indicator, and then we start spinning it. And then we call the setter on the installed property. And then we have this, again, like we're passing code as a parameter here. Then we'll, in this case, set or start animation, or sorry, hide or stop animation rather. Set hidden to yes, so it'll hide the progress indicator, and then it will show the status indicator again. And then immediately after that, we can call, or we can ask if success, remember we created that in the the Cowsay installer class. So if the installation was successful, meaning if that script had exited with a 0 return code, then we on the Cowsay installed status indicator, which again is the little jelly bean, we'll set that to green, which is an image here called NS image name status available. And then we'll also set the installed label to Cowsay is installed. So I think by default, when I'd created it in the UI, it said Cowsay is not installed, as that's probably the more common default case. We'll update that label to say Cowsay is installed. And then set the install Cowsay button to disabled and the say it button to enabled. Otherwise, it'll basically do the opposite, like make the say it button disabled, or it should be by default. And then I think, let's see here, installed status indicator will be set to red. Which is NS image name status unavailable. And then we'll call the installer download and install Cowsay method. And I think that's it for this one. And then this is the last class here. It's the Cowsayer class. And what this will do is take whatever you've typed in that text field, give it to Cowsay, and then get back the actual ASCII cow. So we can do stuff with it, like display it in the UI. In addition, this will actually speak using the say command, or whatever you've typed into that text field. So we have this instance method called getCowsayTextFrom, and we pass it a string, which is just whatever's typed in that box. And you'll see that back in the app delegate. And then we're going to, again, use NSTask to actually run the Cowsay command. And then here I've also created a pipe. So NS pipe and then star pipe there. You can think of that as in Unix parlance, a pipe. So passing like standard from one command to another. And then we'll also use the file handle, and then you pass it, or I'm sorry, we'll call the pipe object file handle for reading method, and that becomes our file handle. And then we set the launch path to user local bin Cowsay, which is where we've installed it, or where the install script puts it. Set the arguments, set the standard output to our pipe, launch, and then wait until it finishes. And what we're going to get back through that pipe is data. So we'll create an NS data variable, and then we'll use the file handle read data to end of file method. And then we're going to, from that data we get back from the pipe, we'll create a string. So with the UTF-8 string encoding. And then we, I don't think I did it here, but it should actually return a string. So it'll return this, the results, which is the what we've read back through that pipe. And then it calls this other method here, say what the cow says, and then that takes a with voice, or I'm sorry, say what the cow says with his voice, and then it takes a string as the parameter. So in this case, we're just going to use Alex. You could set that to bubbles or whatever system voice you prefer. And you might have guessed, but all that does is just use NSTask to run user bin say, and we don't really care if that when that finishes. So we're not going to do what we've been doing previously, which is like wait until it finishes. So we don't want to block the UI waiting for the system to speak, because it doesn't matter. We're not waiting for any value. Right here, the positional arguments that I've created, it's the string that gets passed in this method here, which is what you've typed in the text field, and we separate that by space, which will create an array, right? So if you've used Python's subprocess module, you'll be familiar with the fact that you need to pass the shell arguments as an array to like the subprocess command, or the subprocess module. And then setting mutable args here to array with objects, which is -v. So if you use the say command and you use the -v flag and pass like a name, it'll say using that voice that you've specified. And then we're creating the combining the keyword arguments and the positional arguments. So, and then that's what will end up getting passed to the NS task. So in this case, setting the launch path to user bin say, set the arguments, and then launch. And then I go back up here and actually return the result that I should have done earlier. All right. So now, if I go back to the app delegate here, there's the sayIt instance method that was created through Interface Builder, which is what happens or what runs when I click the sayIt button. But first there, I needed to import the cow sayer class, which I just did. So we're going to create a cow sayer object, and then call the instance method that we created to get the cow say text, which will be the cow, and actually update that in the UI. So we've called our instance, or our object here, sayer, and we call the get cow say text from method, and we pass that the string value from the UI, and that will give us back a string, which is the cow. So we give it words, and it gives us a cow. Okay, and then the last thing down here, it's we use NS user defaults to actually save the cow to our defaults. So if you were to do defaults read whatever domain you give this, you'll actually get a cow, which is with whatever you had typed in last. And that's it. So it should be done. So now if we run this. Let's see what happens. So I don't have it. So if I click on install cowsay, I get it within seconds. I can type in stuff.
Doing a cow thing.
And all that work for that. Oh, and yeah. We decided not to quit it, but we changed our mind. All right. All right, so just a brief overview of what we covered. Basic usage of these frameworks and classes and whatnot in Python, so AppKit, CF preferences, courts, and so on. Like how to retrieve and set preference values, how to determine if an application preference value is forced, how to use the kiosk mode APIs, and how to determine if a Mac screen is locked or if there's a console user logged in. I'm sure a lot of you can imagine ways that might be useful in your organization, so I would recommend checking those out. And the nice thing about those is it's really easy to just get started, and you just, if you already have a shell script that's doing something, it's not that hard to convert it over to Python and start playing around with that. And then in terms of the Objective-C demo, we covered how to use NSTask and NSUser defaults and the NSURL session to make a cow app. So this is just for the purposes of the people downloading the slides on GitHub, just preferences. And that's it. Thanks for all the cows.
Any questions for James? Anyone? No? All right. Well, thanks, James.
Yeah.
Oh, hello. All right, guys, cool. Well, thanks to James and to Jesse earlier. Jesse obviously showed you a cool web UI, and James native apps and how to use Objective-C and Python. That's cool. So I'm just curious, did that give you any ideas of how you're going to use any of this in your on your fleet or in your environment? Like, does anyone need a web UI currently? I'm just curious. Yeah, there's a few. Okay, what about native apps? Did any of that inspire you to go build a native app? Okay, at least one. Cool. All right, well, as you guys know, there's a hackathon coming up, so hopefully these two presentations at least inspired you a little bit to go build a nice web UI. She's going to be going over, or Dana is going to be going over some of the details of Hack the Mac that you know is all coming up. But if you're even just a little bit inspired, I'm sure either Jesse or James would point you in the right direction if you get stuck. But there's plenty of other people here that you can reach out to. Not me. I don't know that much about native, but web stuff I can definitely help with.
You do reach out to Dodge.
We can learn together. Okay. All right.
All right. So a couple of things. The team submission is due this Friday. Now, this could be a placeholder. You don't have to actually put your app name and all the members. You just add yourself.
Hold from the top.
Hold it like this. Okay. Just put your name. You can add team members, but like I said, this is not set in stone. We're not going to come back and say, you need to have your app name be what the cow says or something like that.
Great name, by the way.
But go to macbrained.org/hack-the-mac, and that'll give you all the information you need. It goes back over the theme, some important dates, and the two different categories, user-facing and admin-facing. And there's a link to submit your app, and there's a quick form that you'll fill out. Like I said, do that by Friday. I'm hoping that we get a ton of submissions. If not, we may be extending the date. We'll see. Check our Twitter, check Facebook, and check the website itself to see if that changes. But otherwise, this Friday by midnight, hopefully you've submitted your team and your idea of an app.
And if anyone is looking for a team, maybe you can post in any of those same forums.
Yeah, you can use Twitter, use the hashtag #HackTheMac. Also use Facebook and use Slack. There's a ton of people in the Mac admin Slack team. Who here is on the team and actively participates?
Me as of today. So
I actually got Mike Dodge to join. I'm gonna write that down in my journal tonight. You can find it by going to macadmins.org. From there, you could just put in your email address and sign up. There's tons of great people in there, great channels, great topics. I think there's over 1,500. Did we hit 1,500, Kitsy?
it's nearly 1,500.
Nearly
like
1,500 Mac admins in there, so tons of great resources. And there is the #Macbrained channel that you can go to. I may be starting up a Hack the Mac channel. I think I'll do that. Jason, get on that. Final app submissions are due October 30th. Top 3 announced November 2nd. And we will be having an event where we announce the winners and they present on November 17th at Slack. Cool. Does anyone have any questions? No?
So who participated last year? Anyone? Cool, there's a few. This year, we want to see all your hands up. Come on, everyone can do something. All right, Sam volunteered. He's on record. All right.
All right. I'm going to hold you guys to that. Okay, JNUC. Who here is going to the JNUC? Not as many as I thought. All right, hopefully this is for people that are watching the stream. Our next event is at the JNUC. It will be on Tuesday, October 13th, which is the second day of the conference, and it will be at Day Block Brewing, where we did it last year. We had a ton of fun. We hope you guys can come out, and the Eventbrite registration will be out soon, and I'm sure hopefully people will be registering, will be filling up. I know we sold out last year, so make sure to stay tuned for that. And that's it. I know a couple of you guys will probably be going over to the beer hall, which is kind of across the street. Yeah? I don't know. Follow Wes. I'm sure he's going.
Speaking of that, thanks to
None, I
Square for
volunteered you
hosting. Just let Wes come up and do his spiel now.
We're getting to that. All right.
Thanks everyone for coming. Myself, Tom, who is running AV, and then Kevin, who was here briefly, largely in part to Tom and Kevin.
Yeah, let's give a big hand to Tom. He did a lot to put this on.
I wanted to do nothing. Tom owned this, made it great. So it is 8:32, which means we are 2 minutes past the time that you're supposed to be gone. So we'll all go downstairs. We'll go outside. We'll hang a right, and then the first left, we'll walk across the street, and then we're gonna go to beer hall and we'll grab a brew. How does that sound? Sound like fun? So yes, thank you for coming. I hope you enjoyed your stay. Now get the fuck out.